Thanks, everyone. This is, without a doubt, the largest room I've spoken in front of, and mad respect for a live coding talk that stays within the time limits. That was awesome, Shruti. This talk is all about Apollo client caching and how it's changing in our next major version. I'm Ben Newman, sort of made up this title for the sake of the talk, Apollo client architect. I work at Apollo. You can find me online. I look like that. Benjamin with no I at the end, like Flickr, is my handle on these social networks, my favorite of which is GitHub, of course. I have tweeted a link to these slides, which are a slide.com deck, if you want to find them later, though I will say the mobile formatting is not great. All right. So a trick that I like to play on myself when I'm preparing a talk like this is to start by writing an excessively flowery extended metaphor as the introduction. And then once I have filled in the rest of the slides with actual non-metaphorical content, I'll go back to the introductory slides and thank them for their service and delete them from the deck. If you're curious about how boating and navigation technologies in the Civilization computer games relate to Apollo Client 3.0, be happy to waste your time with that explanation later. But that is all in service of explaining why this beautiful screenshot from Civilization 6 is still in the deck, which I have lightly remixed by superimposing the real question that I want to ask to kick things off, which is, what is or should be the job of a GraphQL client? We, Apollo, call ourselves the data graph company, in case you didn't know, rather than the GraphQL company for a good reason. It's because the truth that we are trying to bring into the world is that your organization, your team, should have a single canonical data graph. It might be sprawling, it might be federated, multiple teams might work on it independently, but it's logically unified by an evolving schema. And that's what's really important. The job of a client application in this context, then, is to replicate just a subset of that real data graph on the client. Of course, it's not going to be the whole thing, probably, but it needs to have all of the same relationships and constraints that matter for your application and its business logic. So just to drive this point even further home, everything we're doing here, everything we're doing to help each other build better apps would still make sense, I think, if the community, for some reason, fell out of love with the GraphQL query language. It's not really the core of what Apollo Client is about. To be clear, I don't think this is a very likely scenario, but I think Neo4j is here. They've come to all of the GraphQL summits. Anyone in the audience from Neo4j? All right, I can say whatever I want. Cool. They have an awesome product, which is a literal graph database, right? And they also have their own graph query language, which, get this, they are calling GQL. So while I think that is a touch confusing, I don't find it threatening in the slightest, because I would be very excited about a possibly distant future where there's a healthy combination of cooperating query languages on the client that mutually benefit from the same client-side data graph, right? And so what that means in my mind is that this client-side data graph should be independent of the query language that you use to request data from the real data graph in the cloud or on your servers or wherever it lives. So what is Apollo Client 3.0, our next major version, all about? It's about giving you the tools to maintain a coherent, efficiently reactive client-side data graph that doesn't have a lot of data fetching logic written by hand. We have borrowed some concepts that were already introduced this past year by Apollo Federation, like composite key entity identity. If that doesn't mean a whole lot, we'll get into details later. And we've got some powerful new tools like garbage collection and a declarative API for managing cached field values. So back when I was going to talk about boats, this itinerary was even then kind of a weak joke. We've already talked about the job of a GraphQL client. The meat of the talk is going to be what's new in Apollo Client 3.0. going to talk about how there's now just one @Apollo/client package. We have cache, eviction, and garbage collection examples to go through, and a unified declarative configuration API. There will be an in-depth pagination example, and if I don't run out of time, I'd love to tell you about some of the underlying technologies, although, because they're underlying, maybe we can skip that. And at the very end, a couple slides about how to get started and where to find the documentation. So, what's new? So, the first big change may seem like a cosmetic change. We have taken a bunch of our existing separate packages and combined them into just one new package. And the great thing about it being a new package is it has no version history. We don't even have to bump the major version, although it will start with 3.0. And if you look at this list, some of them may be slightly surprising, like why are we merging React hooks into Apollo client or a GraphQL tag? Don't those kind of stand on their own? Well, we decided no. Let me show you just quickly what that means. Here's how you would set up a very basic React-based, Apollo client-based app, importing React and then importing everything from Apollo client and creating the client, using GQL to parse your query, or maybe you have a compile time build plugin that replaces that with the abstract syntax tree inlines, and then the rest is just React. So that's it. And let's focus on this part. We think that importing everything from this one package will, we know that it greatly simplifies our job of developing the package, but it also simplifies package installation and versioning. There's no guesswork about which packages export what. Believe it or not, it enables better dead code elimination and tree shaking, especially within the library, so that what we ship is smaller, but also in your applications. And if you don't believe us on that point, there's a link here with some example apps that show how we think you should be bundling things and prove that tree shaking actually will work. OK, so that's one package to rule them all. Let's move on to cache eviction and garbage collection. I think it's safe to say that these are the most important / embarrassing missing features in Apollo client. If you take nothing away from this talk besides this, these are worth studying and trying out in your own applications. I want to make a perhaps fine distinction that this is a tracing garbage collector as opposed to a reference counting garbage collector, and I'll try to motivate why that is, but it's mostly for performance reasons. There's a feature where if you really want to prevent a certain ID and all of the things that it references from being removed by garbage collection, you can explicitly retain it. And I also want to shout out to the other Apollo client, Apollo cache implementation, Hermes, from which I took a bunch of inspiration, especially when implementing garbage collection. So how does it work? By the way, I'm using the sort of teal and indigo color scheme with teal slides as topic, high-level description slides, and then the indigo darker slides are in the weeds. So if you zone out here and then you see the screen kind of change color all at once, maybe start paying attention again because that means we've moved on to a new topic. All right. I hope this is visible. OK, so suppose you have a query where you're fetching your favorite book and you're going to cache it on the client. So at some point in the pipeline, whether you write this explicitly or it happens for you, because the cache does it, you're going to write the first book into the cache. Fahrenheit 451 might have been your favorite book when you were a teenager. And then these aren't actually my favorite books. I was just sort of in a books that have numbers in their titles mood when I was working on the slides. If you end up replacing that favorite book with another book, say 2666 by Roberto Bolaño, then the same query, maybe getting ahead of myself, what does the cache look like now? The cache has a method called extract, which you can use to just get sort of a JSON serializable version or snapshot of the contents of the cache. So this is some code that I took from one of our tests. That's not all. After we've written both books, we have the root query, and then we have as normalized entity objects both of the books and then both of the authors, right? But the same query can can no longer read Fahrenheit 451 or Ray Bradbury out of the cache because all it's going to find is 2666 and Roberto Bolaño. In fact, the old data is now, in some sense, unreachable unless we happen to remember the IDs. So this is a little bit different from automatic garbage collection in a programming language like JavaScript, where when an object becomes unreachable, that's really the end of its story. It is possible to remanufacture these ID strings. So garbage collection here is not always completely safe or sound, and that's why I'll get to the retainment API in a second. But let's just focus for right now on what happens when you call the cache.gc method. And I want to stress that this is a method of the cache. It's not a method that we could have implemented on the Apollo client object. So it starts from the root query, and it fans out, following all of the references that it finds there. And in this case, the only reference that it finds is for 2666, the book, which also has a reference to its author, but at no point is Fahrenheit 451 or Ray Bradbury involved. So then it's able to delete Fahrenheit 451, just burn it with fire, and the cache gets a little smaller, which is cool, maybe a lot smaller. So if you really wanted to keep the object for Ray Bradbury in the cache but didn't care about his books, you could retain him by ID, and we would still be able to get rid of Fahrenheit 451, but Ray Bradbury would stick around. The opposite of retain is release, and you don't really have to think about this API very much because top-level IDs like root query are automatically retained. OK, so that was garbage collection. By comparison, cache eviction is a 2-bullet-point slide. Calling cache.evict with an ID immediately removes any object with that ID, regardless of whether it's been retained. So this is a fairly power tool-y kind of API. And eviction and garbage collection are two great tastes that taste great together, because any data that was only reachable from an entity that you just evicted can be automatically collected by calling cache.gc. So you probably want to do one after the other, although that does not happen automatically. OK, so that was cache eviction and garbage collection. So in preface to the next sequence of slides, I want to sort of define my terms here. When we talk about a declarative cache configuration API, I hope the only word in that phrase that is challenging is the word declarative. So what do I mean by that? All things considered, when you're programming, I would say it's better to tell a computer somehow what you want to achieve in just one place, rather than specifying how to achieve it, like writing a bunch of code in lots of different places, which might be inconsistent with each other. Why is that important? Well, I mean, this is the basic insight of what we call declarative programming. You declare your intentions as simply as you can, and then you trust the computer to find the best way of satisfying them. You can imagine an intergalactic spaceship captain, setting a course for the Alpha Sector and then saying the word engage. Well, that's declarative programming, because when you're traveling faster than the speed of light, you can't play it by ear, right? There's literally no time to react to objects or whole planets that might be in your path. So you have to trust the computer. And I don't mean that this is like a do what I mean interface rather than do what I say. You still have to be fairly precise in how you describe what you want. You may have to write it down in a machine-readable format, but you're expressing your intention, right, instead of your idea about how something should be accomplished. So that's declarative programming. OK, so as a quick example of this, most of the rest of what we're going to be talking about are options that you can pass into the in-memory cache constructor. So a relatively simple one is the possible types option. So as you may know, query fragments can have type conditions like this, where you're getting characters from the Star Wars API, and you want the names for all the characters, and the sides for Jedi characters, and the model for droid characters. Both Jedi and droid are subtypes of character, but a Jedi is not a droid, and vice versa, and they have different properties. It doesn't actually happen all that often compared to the total number of types that you'll have in your schema, that you have subtype relationships between different types. But if you have interfaces, they can be extended by subtypes. Union types can have member types. And it's also, of course, possible to have like subtypes, unions of interface types, unions of unions. So it can get pretty hairy. And Apollo client really doesn't know anything about these relationships unless it is told about them by you. So previously, how would you do this? Well, we didn't have the possible types option. So what you'd do is you would issue a schema introspection query, which looks like this. And although relatively innocuous at first glance, you would dump the output into a file and wrap that output with what we called the introspection fragment matcher. And this is how you did it. I don't want to spend any more time on this because it's embarrassing. So for the Star Wars API, this is what that introspection query looks like. And you'll notice that although each of these types does have a possible types field on it, most of them, virtually all of them, are null. And we don't care about those. That just means this type doesn't have any subtypes. So I think we can do better, right? You want to write down just what you mean, what you want, and not a whole bunch of other junk. Apollo Client 3.0 allows you to provide just that necessary information. So we've got this possible types, objects, the keys are the supertypes, and then the arrays are strings that are the names of subtypes. And you can go multiple levels deep, like a snake could be a viper or a python, and then a python could be a ball python or a reticulated python. Saw a guy working on an app that had a bunch of snakes in it earlier, so I wanted to make this example a little spicier. And I think it's easy to generate this either manually when you're first getting started or programmatically. You can still extract it from the introspection query result, but you don't have to bundle all of the extra stuff into your client application. All right, so possible types is a top-level key in the in-memory cache constructor options. Type policies are another top-level key. We promised in our blog posts in the what's next section when we were announcing 2.6 that we would be removing or consolidating several APIs like data ID from object and the connection directive, and that's exactly what we've done. So type policies is an object that's passed to the in-memory cache constructor via the type policies option. Each key corresponds to a type name, and each value is a type policy object that's just an interface. It's not like a special class. It provides configuration for that type. The configuration is always optional. Most types can get by with the default behavior. After all, that's what you're doing today. And because configuration coincides with cache creation, that means that these rules are enforced for the entire lifetime of the cache. So you don't have to think about when you express this configuration and when it becomes effective. OK, so I used the phrase entity identity earlier. Maybe you remember it because it rhymes. This is the idea that basically you want to write down the primary keys of the objects that are in your data graph. The Apollo Client 2. Whatever way was to pass in a data ID from object function, where you could have a series of exceptions to the default behavior, often with a switch statement on the type name. And by default, if we fall through all the way to the default case of the switch statement, the ID includes the type name and either the ID or underscore ID field. You can tell that we sort of had MongoDB in mind. So the Apollo Federation way, just as a slight detour, as you've seen in some other slides, is to express that information using the key directive. Each of those strings is a selection set syntax, like from GraphQL query syntax. And I just want to stress that this is schema syntax, so it's not directly applicable to the client, but I took it as an inspiration for what we're doing on the client. So the Apollo Client 3.0 way is closer to the Federation way than the Apollo Client 2 way. You have these keys, which are the types that you're trying to configure, and if you don't want the default behavior, then you can say that a product is uniquely identified by its UPC code, or a book is uniquely identified, hopefully by its ISBN number, right? But also maybe, if you don't have that information, by its title and its author's name. And the nested array syntax here is meant to resemble nested selection sets. So that name in square brackets applies to the previous key, the author. We might introduce a parsing step here, so you can just provide a string that looks exactly like the Federation version, but it seemed like a good place to start. So behind the scenes, a typical book ID might look like this for Fahrenheit 451. All right, so what problems do I think this new API solve? Field names are reliably included along with their values. So title and name and author are part of the key, so there's no ambiguity about which values are which. That would be kind of annoying if you were writing that by hand in the data ID from object function, but you're not. The order of the fields is fixed by the same order found in the key fields array, rather than by object property creation order. So we no longer need to do the sort of stable JSON stringify shenanigans. You don't waste any time executing logic for unrelated types, because either your type has a key fields property or not. Not an opaque function like data ID from objects. So the client has an opportunity to sort of inspect this configuration and warn about any missing key fields in objects that come back in your responses. You may want to add those fields to your query. So this is a very fine point, but it's never confused by query field aliasing, right? The names in the key fields array are just always the actual schema field names, even if you happen to rename those fields using aliases. So you don't have to think about that. You don't have to stop yourself from using aliases for primary keys. And this configuration, maybe most importantly, can be pretty easily code generated from your schema, which means that you might not even have to write it by hand. I would say, since we're talking about normalization and entity identity, that not all entities or not all objects have real identities. So it is possible to disable normalization now in Apollo Client 3.0. Matt had an example earlier of search results. The key bit here is that you just pass false for key fields to say that something should not be normalized, and that disables the default behavior of using ID. I'm going to skip on to the next section, since we are close on time and coming up on lunch. So fields, of course, are the properties of entity objects, like the title of a book object. However, in GraphQL, query fields can have arguments, right? So a field's value might not always be uniquely identified just by the name of the field. So the cache might need to store multiple distinct values for a single field, depending on the values of the arguments that were used. So it turns out that fields also have identity, sort of in the same sense as entities. This is an example of a feed query, maybe inspired by Facebook's use cases for GraphQL. By default, the cache will store a separate value for each unique combination of arguments, because it just doesn't know what those arguments mean or which ones might be important. It was a pretty good default behavior, but it becomes problematic for arguments like offset and limit, since those arguments aren't really supposed to alter the underlying data. They just kind of filter it. So the traditional way of accomplishing this has been to use the connection directive, which is something that we cargo culted in from Relay in Apollo Client 1.6. And you can see that it's saying we only care about the type argument on whatever the fourth line there. And that was a way of telling the client which feed fields are important. And it solves the problem, for sure, but it's kind of repetitive, right? Because this is query syntax. So you're going to have to write the same thing in every query where you need this behavior, right? And then those different connection directives can be inconsistent with each other, which leads to duplication and inconsistencies in the cache. things fall apart. So Apollo Client 3.0 allows specifying key arguments in one place, again, when you first create the in-memory cache. Like key fields, it's an array of strings. It's always just an array of strings and never nested. And it's called key args instead of key fields. So once you provide this information to the cache, you never have to repeat it anywhere else, because it'll be uniformly applied to every query that asks for the feed field within the query object. You'll note that we're sort of inside of a type policy for the root query object here. OK, so I'm going to cover the rest of this vertical somewhat quickly, because the next example actually goes into more depth. In addition to key args, you can specify what happens when you read a field and what happens when new data comes into the cache for that field. So those functions are called read and merge. They look something like this, and this is all going to become quite a bit clearer once we look at Apollo Client 3.0's brand new treatment of the important pattern of pagination, which is, of course, the pattern of requesting large lists of data in multiple smaller chunks or pages, currently achieved with the connection directive, the fetch more function, and its update query option. Apollo Client 3.0 has a new solution. You just saw very quickly the necessary ingredients. So here's a React Apollo query where we're using fetch more and update query and concatenating together the books, as you can see on line 16. Otherwise, they would just sort of overwrite the old books. We're going to focus on this function because this code would need to be repeated anywhere in your application where books are consumed. And in Apollo Client 3.0, you can actually just delete this code, and then you don't have to deal with its subtle bugs. If we wanted to do something more complicated than what it's doing, we'd have to repeat that complicated code everywhere, and maybe it's just not worth it. Maybe you don't go to the trouble of getting things exactly right, and that's a shame. So with Apollo Client 3.0, as I said, we can delete this and use a custom merge function instead. So what should we put in our query books field policy? Well, first of all, if you're going to do this, you want to just sort of take full control over the interpretation of arguments. So just like we could pass false for key fields, you want to pass false for key args, and then the cache will store a single value for this field within each parent object, rather than having different flavors of the same field. But you're not giving up your ability to interpret the arguments, because, in fact, that's what the merge and read functions are for. So merge will be called whenever there is incoming data for the field. The very first time, the existing data will be undefined, so you want to deal with that case. But if we want to just do exactly the same thing that the update query function was doing, that's a one-liner. And then the read field can slice that existing data using the offset and limit. And that's great. These functions are already working together to do exactly what update query was doing. But it also has the same bugs that the update query function had. So just for example, you might want to guard against the case when the existing data in the read function is undefined, and return undefined in that case, which the cache will handle gracefully. And in the merge function, you might not want to assume that the incoming data will always just be the immediately next page in the list. So we can do a better job of handling offset and limit, which we could do by making a copy of the existing data and then sort of writing the new data into the actual positions that are specified by the offset and limit arguments. All right. So this code is already a bit more complicated. Like you wouldn't want to have been writing this everywhere you wrote an update query function, but you only have to get it right once, which is the whole virtue of this new cache configuration API. So once per in-memory cache is definitely an improvement, but what if I told you you only had to write this code once ever, period, right? Nothing about this code is specific to books. We could take all of this logic and wrap it up in a helper function, and then that's the code that you have to write. Reusability for the when, and here's the offset limit paginated field helper function in all of its glory. It just returns a field policy, which is unrelated to the name of the field, so it works for anything that has the same pagination behavior based on offsets and limits. Pagination is notoriously tricky. You might be using cursors, trying to deduplicate or sort or merge, et cetera. But you can do all of that with this API. So one more thing. If we also have a root book field in the query that maybe reads books by their ISBN number, it's possible to define just a one-off read function for that field so that you don't actually have to request that field from the server if it's already somewhere in the cache. And this is such a common pattern that there's even a shorthand syntax for it using shorthand method syntax. This kind of replaces the old cache redirects API, if you were ever forced to understand what that meant. And we're so happy with the results that we've just completely removed cache redirects from the cache. It's not, there's no graceful deprecation story there. That's the shorter syntax. Great. So field policy functions are, I hope you can tell, good for a lot more than just pagination. In fact, in a read function, you don't even have to look at the existing data. You can return whatever you want. And if you're familiar with how local state works in Apollo client, you may be wondering, wait, does this maybe replace local state? And this is the kind of possibility that really makes a web developer like me salivate. Let's just remember that with local state, if you use the @client directive on a query field, what that means is that the client will read it from the cache, right? Even if you don't have a resolver function, if there's no custom behavior, it'll just come straight from the cache. So if the cache has a read function for that field, then you can put the same resolver logic in that read function. So if you can define arbitrary field read functions, you might not even need to define a local state resolver function. So could we just delete the local state implementation? And I mean, this is so tantalizing, right? Because the amount of code in that implementation is enough to pay for all of the new features that we've added in Apollo 3.0. So the net increase in bundle size is close to 0. And if you don't care about that as much as me, that's OK. But it's something I would really love to see. One thing that's holding that back, though, is that read functions are synchronous. So in order to deliver asynchronous results, we need to have some sort of React hooksy style way of invalidating their results or letting them invalidate their own results, which is definitely a to-do. But for now, you'll need to stick to synchronous stuff in these read functions. OK. We are out of time, so as predicted, I'm not going to tell you about how the entity cache is an immutable data structure that's very easy to snapshot, but has a lot of benefits, and I'd love to talk about how we made that efficient. How do you get started? Well, you can just npm install Apollo client at beta, and then try to start using the new exports rather than the 2.0 exports. Once you've finished that admittedly burdensome task, I hope you feel like every change was worthwhile. You can just remove all those other packages. Feel free to click on through to the release 3.0 pull request for the most veridical record of all the action that's going into this release. Again, it is a beta release. I think with Apollo Client 2.0, we made a bunch of changes and announced at Summit that it was ready. And then a lot of people found out that it was actually kind of difficult to accommodate those changes, and we don't want to repeat that. So we look forward to your feedback on the beta. Documentation, we have some. Those are some links to the pages that are in especially good shape. And it's a work in progress, as always, but it's a little less incomplete than ever before, thanks to some crucial new hires on our documentation team. This guy, Stephen Barlow. It's great. Has changed my work life more than any other single person. All right. I'm just going to leave this slide up as my last slide. This is a cheat sheet for all of the existing features that we've either removed or deprecated or made avoidable or consolidated and what the replacement is. Of course, if I put this up at the very beginning, none of it would make sense, but I hope that I've explained each one of those things in enough detail that this is a useful resource. And I would say that all of these replacements are superior to what they replace because they're declarative and they're non-repetitive and they're consistently applied throughout the lifetime of the cache. All right, you got that? Let's do this.